In the ever-fascinating world of chemistry, we're beginning to look at the concept of thermochemistry. Thermochemistry is study of the reaction of the process that results in release or absorption of energy. Now, when it comes to energy, we find energy defined as ability to do work. The way we find that is energy is equal to the Q, the enthalpy, plus the work done. Now, when it comes to types of energy, there are two types, either kinetic or potential. The equation for kinetic energy, Ke is equal to 1/2 mass times velocity squared. Potential energy, GPE, gravitational potential energy, is equal to mass times gravity times height. Now, we're looking at enthalpy specifically. Enthalpy is defined as the energy associated with the movement of heat. Okay, and there's two ways that I can determine that. It's either delta H like we did last year, or this year we'll express it as Q. All right, most intro books call delta H, most college levels call Q. Since we're preparing for college, we're going to call it Q. Now, enthalpy of a reaction is the amount of energy released or absorbed in a chemical reaction. Now, we have two ways we can either have this. Either the enthalpy, delta H or Q, is negative, or it's positive. Now, if it's negative, the reaction is exothermic. If it's positive, the reaction is endothermic. And again, remember, exothermic energy is releasing, exiting out. It's getting hot. Endothermic is absorbing, entering in. It's getting cooler or requires energy to go. So look at a problem here. Determine the energy released at 35.988 grams of methane as it burns. If the enthalpy of the reaction is negative 67.977 kilojoules per mole. You see that's negative. That is an exothermic reaction. All right, so let's start with the reaction. Methane burning combustion, so CH4 plus O2 is yielding CO2 plus H2O, balancing it up. Goes like that. All right, so we take our mass and then we convert it to moles, a balanced equation. 1 mole of CH4 is 16 grams of CH4. From the negative 67.977 kilojoules per mole, for every 1 mole of the reaction is 67 kilojoules of energy. Multiply through, we get 150.74, but remember it was negative, so we either say it's negative 150.74 kilojoules, or we can say it's 150.74 kilojoules of energy released. All right, that's our answer. Okay, here's the second problem. Calculate the energy needed to initiate the reaction of 45.77 grams of ammonium nitrate with barium hydroxide if the delta H, or the Q, is 10.225 kilojoules per mole. This is positive, this is endothermic. We'll do this in class. And then the last one, what is the mass of sodium oxide is synthesized if 25.78 kilojoules of energy is measured and the enthalpy of reaction is 765.88 kilojoules. That's it for today. Take care, be good, bye.